Okay, we'll look at IPv4 first up, and we'll look at v4 and subnets and all the rest of it, and then hopefully it might, when we get down to the slides at the end for v6, make it fairly easy. It's pretty simple. So, and again, we'll look at motivations to change. One of the things I saw in the last 2 weeks is that the IPv4 address space for allocation in the United States has run out. They have no more addresses to actually hand out to people. So it has finally occurred. The Internet Management Group that manages v4 addresses has no more in the US. So yeah, there is going to be a big push to shift. So that's a big motivation for change. Run out, like many things. So TCP/IP stands for Transmission Control Protocol and Internet Protocol. Okay, so lots of things we get into over the next 5 weeks are all about protocols. They're just basically standards for how to pass things across the pipes that both ends understand. That's all a protocol is. It's a way we talk. Okay, so there's a pretty good blurb on protocols and Internet Protocol suite there. Now, be aware, TCP/IP is just one protocol that runs on top of the physical stuff we've done so far. There are others. There's IPX, there's Ethernet IP, which stands for Industrial Protocol, not to be confused with Internet Protocol. There is a whole bunch of mainframe stuff that runs over the same physical stuff. So TCP/IP is the most popular version, but it is only one of the protocols that moves data around the place. So the basic building block of networks is the IP datagram. So we've seen this a little bit when we looked at Ethernet with packets, and we touched on IP. Okay, the address of the computer, where it's going, where it's coming from. So the analogy in this space is very much a postcard or a letter. There's a destination address, there's where it came from, and there's a bit of text, the payload of the packet. Okay, postcard might tell you about holiday travels, or in my case some theatre I've been involved in lately. Remind you of a dentist appointment. And again, the Postal Service doesn't care. Okay, which application, friend, dentist, web browser sent it. It just carries the stuff from one point to another. Okay, so the IP datagram doesn't care what's in it. It just shifts stuff around. So, as I muttered through in the intro, we've looked at this physical layer. This is your Ethernet. This is your fiber. Okay, sometimes it includes the data link layer. So what we're up to here is these two layers. Okay, TCP/IP is up in this chunk. Okay, that's where it sits. This is where it runs. So we're working our way up the stack. And when we get down to the end of DIT, and we're talking about things like websites and web coding up web pages and WordPress and stuff, then we're up in this part of the process. So again, the OSI stack. A little bit of a brief recap. Okay, stuff, your web browser up here. Okay, does things. Wants some information from a web server over here. The data that's got to go across the stack starts here. As it goes down through the layers, it gets encapsulated. Bits get added. Okay, so it's fully transparent as it goes down the stack. Okay, each layer doesn't actually need to know what's in the packet. It just adds its own stuff. Okay, as it goes down the stack, and then it decodes it as it comes back up the stack on the other side. Okay, so when we get down to this chunk here, these pieces in the front is what we're examining in the TCP/IP space. Okay, these bits that are going on the front, this is where the protocols sit. They encapsulate that data that's handed down from further up, and then they break it out again on the way back up. So, the IP addressing structure. Okay, remember, computers do not understand dots and all the rest of it. Computers only understand zeros and ones. Okay, so to the computer, the IP address looks like this. We write them like this to make it easier to remember. Okay, so 192.168.1.5 is the IP address of this particular computer. So V4. Okay, it says current is the current most popular. Not everyone shifted to V6, but the majority of the internet infrastructure out there is dual stacked. It has V4 and V6 out there. I had to move to an Optus plan here at home for my internet, which made me a bit grumpy because I was with Internode, whose entire network is dual stacked, natively V6, and I liked it very much. Optus isn't there. They're still V4, and from looking at it, they actually have NATing in their own network as well, from looking at some of my network traces here. So it's a bit interesting. So this breaks down. So this is your 192.168, okay, .1.5. So this is how it is used by the computers. So again, the dots are just breaking things up, and the dots we'll see come in with subnetting and the original way that that the addresses used to be, well, the way that networks originally were designed to be broken up, which changed over time. So standard 8-bit binary to decimal. So okay, a 1 here, 64 here. So if you haven't used it, your standard calculator in Windows allows you to go into a full scientific or programming mode, and will give you binary digital conversion. So I haven't actually played with it. If we get a moment, I might just crank up the calculator and we'll see if the one here works. So standard 0 in any position means 0 is added to the total. So you add it up, the end there, that's 5. Okay, 1 plus no 2s plus 4. So that's 5. Fairly simple. So again, converting it decimal to binary, nice flow chart here. How to convert 172 to binary. So start, work down. Pretty simple. Start with the biggest. Do we? Is it greater than 128? Yes, it is. Good. Okay, we put a 1 in that spot. Okay, and we take 128 off it. Leaves 44. Is 44 bigger than 32? Yes. Okay. Sorry, no. So we put a 0 in the 64, so we get 1 0. Yes, it is. We add another 1. That adds to 32. Okay, greater than 16? No. So you just work your way down from biggest to smallest when you're doing the decimal to 8-bit binary conversion. So fairly simple. Again, nice tool on the web there if you need to do digital binary conversions. So that's to get from your 0s and 1s to your decimal when you're looking at IPs and fiddling around with them. Originally, you'll hear people talk about things like C-class addresses and B-class addresses. All that means, okay, is that when we're looking at the subnet portion over here, is how many 255s there are, okay? So a B-class means that the network part of our address is the first 2 bits. So if we're looking at our 192.168, the network part is the 192.168. Okay, that's all the subnet does is say, okay, those first 2 chunks there are our network. Okay, that's the network. And then the 1.0 chunk, or the 1.5, this part tells us the computer. Okay, or the actual host, the address. So in the case of a B class, you have 65,534 potential computers on that network if you split it at the halfway point. Much more common was a C class address. Okay, we split it at that point. So that gives you lots of 2 million networks and 254 computers on each network. So originally, when the network was being put together, an organization would get handed out a network. Okay, they would be given a number between 128 and 191. and that would be their network. The problem was they very, very quickly ran out of networks because lots of people snapped up these big ones, at the beginning. So you'd have companies that only had, a couple of hundred computers actually sitting on 65,000 addresses. So, this was the original way that they went, yep, we'll do it like this, okay? So when you see down here some of the other odd ones, okay, there's a couple of network ranges where you see the first octet at the beginning, the range, the 224 to 239 in that first chunk. So, you got lots of dots. So this first chunk here, okay, and then you've got a number, dot number, dot number. So if you see an address that's got a 224 through to 239, then it's a multicast address. So that's a specific type of network address that can be broadcast from one computer, and lots of other computers can subscribe to it. So, when Apple or Elon Musk is doing a web broadcast, it comes out over multicast, okay? So if you look at the actual packets that flow, it'll start with one of these addresses, okay? It's a send once, consume by many. So it's what multicast is. You can subscribe to what's being fed from that from lots and lots of computers, and it only gets sent out once. So this is where a whole lot of video distribution works quite nicely. So again, if you see an address that starts in the 240 to 255, they're experimental IP address ranges, and they're locked off. So you shouldn't see those in the wild out doing stuff. They're for doing experimentation with. So originally, 1 to 127, A's, 128 to 191, B's, 192 to 233. So those are how the addressing scheme for v4 was originally supposed to work, okay? So up at that level, 16 million hosts, 65,000 hosts, 254 hosts, okay? There's a couple of special cases, like the 192s and the 10 and the 172 addresses. We'll get to those in a minute.